Okay. So we are going to start with chemical periodicity. Okay. Mm. So first discuss what does this periodicity mean. So we can define periodicity as the repetition of chemical properties after a regular interval of elements when they are arranged in increasing atomic number. See, so we define this as a periodicity. Now, if you want to understand this, so let's have a look at it of the periodic table. In periodic table here in this, okay, just let me do this thing. Here I have a group 1, then here I have a group 2, then after the gap of 10 elements, I have a group 3 over here, group 4, then group 5, group 6, group 7, and group 8, whether we call them 13, 14, 15, 16, 17, and 18, right? Okay. Now, here we have a periods. So in the first period, in the middle, you are going to find hydrogen over here and the helium over here. Then in the second period, we're going to find a lithium, then beryllium, and after the beryllium, you have a boron, carbon, nitrogen, oxygen, fluorine, and neon, right? And then right after them, we have sodium, that's a third period, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon, right? So this is the periodic table, and I have drawn the first 3 rows or the first 3 periods, and I have shown you the arrangement of the element in this. So if you look over here, its atomic number is 1. Then you got 2 over here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Now, if you read the statement again, what this statement is telling you, it is telling you that it is the repetition of a chemical properties after a regular interval of elements when they are arranged in increasing atomic number. This is not necessary to write every time. This is how the elements are arranged in the periodic table. But this thing, that repetition of a chemical properties after a regular interval of elements when they are arranged. Okay. So see over here, if you look at this arrangement, if I start from the lithium, what is the position of sodium over here? Starting from the lithium. Yes, can anybody tell me the position of sodium with respect to lithium? Yes. Riza.
कोई समझ नहीं आ रहा.
I am asking, if you start from lithium, then at what position sodium is present?
11th.
No, 11th is from the start. But if you start from lithium, then
8.
lithium will be first, second, third, fourth, fifth, sixth, seventh, eighth, and the ninth. From lithium, sodium is at the ninth position, right? Is this understandable to everyone?
Yes.
Okay. Now, if you look at beryllium and magnesium, magnesium is also at the ninth position with respect to beryllium. Yes.
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 In the same way, aluminium is at the ninth position with respect to boron. Silicon is at the ninth position with respect to carbon. The phosphorus is at the ninth position with respect to nitrogen, and so on till calcium, as potassium is at ninth position with respect to sodium, and calcium is at ninth position with respect to magnesium. So see, at every ninth position, when we arrange the elements in such a way, every element which comes at the ninth position is actually having a same electronic configuration as the one above, and that's why their chemical properties are repeated, and we are observing the regular repetition of the chemical properties at the ninth element. So see, that is called that this is occurring at the regular interval. Is this understandable? This means periodicity. If anybody have any doubt in this, kindly ask. किसी को भी बेटा कोई confusion है या ये बात समझ में नहीं आई है तो please पूछ लें. सबको क्लियर है ये बात? Yes, Abdullah, Alia, Amna, Arika, Dawood, Hamza, Nuria, Shariar, Simra, Tayyab, Bariza. If anyone have doubt, do ask. तो क्या हो रहा है कि इक्वल इंटरवल्स पे केमिकल प्रॉपर्टीज की रिपीटिशन मिल रही है, ठीक है? और हमने क्यों बात की कि ये रिपीटिशन मिल रही है? क्यों? क्योंकि जो एलिमेंट है आ रहा है उस इक्वल इंटरवल के बाद वो एलिमेंट सेम ग्रुप में प्रेजेंट है, और अगर वो एलिमेंट सेम ग्रुप में प्रेजेंट है तो इसका मतलब ये हुआ कि उसकी प्रॉपर्टीज सेम होंगी. ये तो आप ओ लेवल से पढ़ते हुए आ रहे हैं, ठीक है? But why this is same? That is the other thing that you have to remember or know. Yes, why the elements have a same chemical properties? Can anybody comment on this? Yes. Elements having same chemical properties means they have same number of electrons in the valence shell. So from this, I can conclude that the chemical properties of element depend upon the number of valence electrons. If the valence electrons, two different elements have a same number of valence electrons, it means they have a same chemical properties. Is this clear to everyone? Okay. Then next we are going to discuss the period 3 elements trends in their physical properties. So here, the first trend I am going to discuss is of atomic radii, and we are going to discuss all these trends for group 2. So first element you have sodium, then afterwards you have magnesium, then aluminium. No, yes, then aluminium, then silicon, sodium, magnesium, aluminium, then silicon. After silicon we have phosphorus, sulfur, chlorine, and argon. If we look at into their number of electrons or the number of protons, sodium have a magnesium 12, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, and argon 18. Okay. So first, let's talk about the atomic radii. I can say that it is a distance between nucleus and valence electron, right? But as the valence electron is in continuous motion, and if we talk about shell, shell is the way how the electrons are moving. There is a no, physical thing that is shell. It's an imaginary boundary. The shell is. So, for example, if I have a nucleus like this, and I have a shell like this, where the electron is orbiting, and if you try to, that is the actually radius, right? But the important thing is that this distance is not measured in this way. We can't measure the distance in this way because where the electrons are moving is the imaginary boundary. So we don't know till where to measure it. So this distance is not measured in this way. So how can we do this? We can do this, for example, if we have a structure where there are two atoms which are neighbor to each other. So what I can do, I can measure the distance between the nuclei of the two atoms. That is measurable because the nucleus is the center, lies in the center of the atom, right? So this distance can be measured, and this distance is actually considered as the diameter because it is the distance from the one nucleus to the other nucleus. So if I have to find the radius, I have to divide this distance with the 2, so I will get the radius. Is this clear? Yes, if anybody have any confusion, do ask. Is it clear to everyone? And the other important thing.
सर ये डिस्टेंस दो नेबरिंग के दरमियान में होता है ना, ओवरलैप तो नहीं हुए होते ना ये?
That's what I am going to tell you. Right now we have just observed the example of the atoms which are neighboring to each other in the metals. Okay, in the metals usually this is the case. And for an isolated atom, I cannot able to, measure its distance, measure its radius. Yes, Nuria, is it clear to you now? They are not overlapping because this is metal. Now think, for example, if you have a substance having a covalent bonding in it, then what would happen? Then there must be an overlapping between the two neighboring atoms, right? And due to this overlapping between the two neighboring atoms, when I record this distance, I can record this distance, and from this distance I can able to record the radius, but the value is smaller than the actual as overlapping or due to overlapping. Is this point is understandable to everyone? Yes.
Yes.
Okay. Now, if we have a noble gases, then in noble gases the neighboring atoms are actually little far apart from each other. So there would be intermolecular forces or the van der Waals forces between the two nuclei. And here I can also able to measure the distance, the but this distance can give me the radii, but the radii that I get from this, the value is greater than the actual one. Yes, is this understandable to everyone?
Yes.
If anybody have any issue, do ask. So see over here that in this, if you point out, you would see these are metals and these are non-metals having showing the covalent bonds, and this one is a noble gas. But the another important thing to note over here that moving from sodium to magnesium and magnesium to aluminium and then so on in the periodic table, which value is actually increasing if you see? Yes, which value is increasing? Sorry?
Atomic number.
Atomic number, and what does atomic number refers to?
Number of protons.
Number of protons. Okay, good. So the atomic number refers to number of protons. So when I move from left to right, this would be a minute, please. Let's suppose if I specify in period 3 or in any other period, the atomic number is increasing, which means the number of protons increases, right? But what happened to the number of shells? Yes,
Same, sir, it will remain.
because it's a period, so the number of shells remains same, right?
Yes.
But the number of shells remain same. And if this is the case, then can I say that the nuclear forces of attraction increases? And if it gets stronger, the attraction gets stronger. So the nucleus actually attracts the electron shells with a more force. So this result in decrease in size of atomic radii. Yes, is this understandable to everyone?
Yes, sir.
Okay. Sometimes examiner asks you to draw the graph for 1 mark as well. So for that graph, normally examiner doesn't ask you to draw for the argon or the for the noble gas, because if I point the noble gas over here, as we discussed earlier, the calculated one would be no, the actual atomic radii of the argon would be smaller, but the calculated one is actually is like this much bigger due to the van der Waals forces. Is this point is understandable? So normally, if the examiner asks from sodium till chlorine, and you have to draw like this, which is showing the decreasing trend. So this is the okay. Let me draw over here to make you understand. But when you calculate it, this would be the calculated atomic radii of argon, as it have a van der Waals forces between the atoms. Is this clear to everyone? Yes. If anyone have any confusion to ask. Atomic radii, I think, is clear. Okay. Now, next one. Ionic radii. So, now if I'll write the ionic, the ions of the period 3 elements. Okay, just do one thing. Repeat it from here. If I talk about all these all are atoms, right? And if these all are atoms, it means all of them have 3 electron shell, because they all belongs to period number 3. Is this clear?
Yes.
Okay. Now, if I made ions, then see, when they become ion, sodium become +1 ion, magnesium become 2+ ion, aluminium become 3+ ion, silicon become 4+ ion, phosphorus become 3- ion, sulfur become 2- ion, fluoride become 1- ion, and there is no need, there is no ion of this one, right? Is this clear? So here I can comment that these four have now 2 electron shells, right? And these three have 3 electron shells. Is this understandable?
Yes.
So from this, can I say that cationic size is always smaller than an ionic size in the same period, right?
Yes.
If anybody have any confusion, kindly ask. Okay, then. So, if I comment on these cations, I can do it that from sodium to silicon, ionic radii decreases. Is everybody agree on this? And why? If I, because the number of shells and the number of electrons remain same while nuclear forces of attraction increases due to increase in number of protons. Yes, am I audible?
Yes.
Okay. So
सर आवाज कट रही है। सर आवाज अभी तक कट रही है।
Yes, am I audible now?
Yes, sir.
Yes, sir.
Okay. Okay, that's good. So here what we yes, my screen is shared.
Yes.
Yes, sir.
Yes, is my screen is shared with you?
Yes, sir.
Okay. So here what we find. Yes. Yes, repeat please. Yes, Abdullah, are you saying something?
No, sir.
Anybody else was asking something? Okay. So see, in each case, from sodium to
सर वापस से अटक रही है आवाज।
magnesium, the number of
सर कुछ भी समझ में नहीं आ रहा।